let's go ahead and get going, and maybe we'll get done early. Well, I mean, we will get done early if we keep going. So, because I think this one is shorter than the last one, but we actually have to do the addition. Section 7.4, we are finally to the addition and the subtraction of the rational expressions. And just like fractions, when you add or subtract rational expressions, you have to have a common denominator, which is why we were just practicing getting a common denominator. Okay, so that's what we're going to be working on, and let's do some examples. So the first one is really easy because why?
Because it already has it.
It already has a common denominator. And if it has a common denominator already, your answer, your denominator doesn't change. It's common between these two. It's going to be common with your answer. It just stays as it is. Okay? Now, when you add fractions, once you have that common denominator and you write it down, all you do is add, not multiply, but add these two pieces. So we add like terms. What do we get when we add x plus x?
2x.
2x. And what do we get when we add a -4 plus an 8?
-4x.
No, you're adding -4 plus 8.
Plus 8.
4. Yeah, plus 4. Okay? And that is our answer. So like I say, once you get a common denominator, the adding is usually not too bad. Getting the common denominator is the hard part. We don't have to factor on these because we've already got a common denominator. Now, I will tell you that as time goes on, if we here's what would happen if we factored these. So I do want to show you what happens. So if we factored this, this would be 2 and x plus 2 on the top. Okay, we can factor out a common factor of 2. In the denominator, we would have x. Oh, we do need to factor this one. X minus 4 times x plus 2. So when we factor this one, do you see what happens? They have a common factor. I should have made us go through it, I guess. But they have a common factor, and just like in the simplifying that we did in 7.1, we can cancel these because they are exactly the same. Do we see x plus 2 and x plus 2 are exactly the same? So we can go ahead and cancel those, and then our reduced answer is going to be 2 over x minus 4.
Do we have to do all that?
Yeah, you should. I mean, you should check it. Now, a lot of times I'll just tell you, you won't be able to factor the numerator, the top, and so you won't be able to cancel with the denominator. So sometimes you'll just see it and you're like, oh, we can't factor this, so we're done. But if you can factor it, there will be times where this will happen and it will reduce. They couldn't just leave it super easy where they give you a common denominator and let you do it. No, they have to make you factor. I guess they made me factor. But this is the key. Once you have a common denominator, you just add straight across. Just add the like terms. So x plus x, 2x, -4 plus 8 is 4. And you just write them down. And then, yes, if you can factor the numerator, if you can't factor the numerator, I wouldn't worry about factoring. But if you can factor the numerator, go ahead and do that, and then see if you can factor the denominator and see if anything cancels. I'll just tell you, usually you will already have the denominator factored because you will have to find your common denominator, and then you'll already know what the denominator is as factored. That's why I said don't multiply it back out, leave it factored. Before I go on, are there any questions on that one? All right, let's take a look at this one. All right, so subtraction. When we subtract, remember how with division we multiplied by the reciprocal? When we subtract, we want to add the opposite. So let me show you how we add the opposite. Again, we don't touch the first thing. 6x minus 12 over 3x minus 6 stays exactly as it is. And our denominator, 3x minus 6, stays exactly as it is. That doesn't change. The only thing that changes, and I'm going to use green to highlight what's changing, the only thing that changes is this becomes a plus sign. So we change it to adding. And these become opposites. So it'll be negative 15x because it used to be a positive, and this will be a plus 6 because it used to be negative. So whatever signs are there, they switch. And I'll just tell you what I usually do when I'm doing a problem like this is I will just take my pencil and I'll put a mark there and a mark there and a mark there, and then I've changed all the signs. So you don't have to completely rewrite it unless you want to. I guess you're going to have to write it down anyway because you're doing it on a computer. So you'll have to write it down on your paper. But that's what I usually do just to save myself having to rewrite the whole thing. And notice once again, common denominator, right? And when we add with a common denominator, we simply combine like terms. So 6x minus 15x will be what?
Negative 9x.
Negative 9x. And negative 12 plus 6 will be what?
Negative 6.
Negative 6. And our denominator is 3x minus 6. All right, now again, they gave us something that we can reduce. So what can we factor in the numerator?
3.
A 3. And actually, we would probably factor a negative 3. So factor a negative 3, and what's going to be left inside the parentheses?
3x.
3x plus
2.
2, right? Okay. So then let's see, since we could factor the numerator, let's go ahead and factor the denominator. What can we factor in the denominator? A 3. And what's going to be left down there? X minus, be careful, x minus 2? Because we're dividing, right? So what do we see that we can cancel?
3.
The 3's. Now remember, this really means negative 1 times 3 when we have a negative 3, right? So we're canceling the 3's. Does that make sense? The negative 1 will stay there. So I would write that answer. And you don't have to write the 1, but a negative and then 3x plus 2 over x minus 2. And again, we can't cancel anything out because the factor on the top does not match up with the factor on the bottom.
So we have to leave that negative like that?
You mean, could you distribute it? Is that what you're asking? If you wanted to distribute it, that's fine. But there's not really any reason to. Because like I said, eventually the goal with these, not in this class because we're not going to do it, but eventually the goal is going to be to have everything as factored as possible. Okay. Any questions on that one? Besides, I can't see it because it's glaring. Hopefully the video isn't too blurry, too glary. Okay, so here's one, and we have to be careful here at this point now. And again, this is kind of back to chapter 5 because there's no factoring that we need to do. But notice these do not have a common denominator, do they? So we need to get a common denominator. So let's see if we can do it without writing them out. If we need to write it out, we will. But let's see if we can do it without writing out all the individual terms. So if I'm looking at 3 and 6, what could we, I don't know if that's a good, what could we turn them both into? I don't know a good way to answer that. What's the least common multiple between 3 and 6?
6.
It's just 6, right? Because 3 times 2 is 6, and 6 times 1 is 6. So we can, using multiplication, we can turn them both into 6's. Now, what should the common denominator, what should the A part of our common denominator be? How many A's do we need? Remember that question? What's the biggest number of A's that we have? And you're exactly right. A squared. So we're going to need A squared in our common denominator. And then we look at the B's. And again, we're focusing on the denominator right now, not the numerator. Focus on the denominator. How many b's will we need in our common denominator? 4, because that's the biggest number of b's that we have is 4. So before we go on, let's pause for a second. Is everyone okay with how we got that common denominator? The 6 is questionable?
Yeah.
So remember what this was. 3 is just a 3. 6 is 2 times 3. So you look at how many 2's do we need to have? We need to have 1, 2. And how many 3's do we need to have? Well, we need to have 1, 3. So we need a 2 and a 3. So, I mean, we could write it out just like we did with the earlier ones. But if you can think of it, you don't have to write it out. But if we need to, we can. Okay? So this is our common denominator. And we've got it set up here. What do we have to multiply this first fraction by, this first denominator by? And let's just do it one piece at a time. What do I multiply the 3 by to make it into a 6? 2. So I have to multiply the bottom and the top. What do I have to multiply the a squared by to turn it into an a squared? Nothing, right? This a squared is already an a squared. Does that make sense? And then what do we have to multiply the b by to make it into b to the 4th? We've got how many b's here already?
3. 3, we got 1.
We got 1, and we need
3.
3. So we're going to multiply. Well, we need 4. So we're going to multiply by. We need 3 more, is what you were saying, right? We're going to multiply by b cubed. So we have to multiply the top by that same thing, and that is going to give us 7 times 2 is 14. A and b cubed. So as that denominator changes, our numerator has to change in the same way, right? By multiplying by the same thing. All right, let me use blue. Okay, so now we go to here. What do I have to multiply 6 by to make it into a 6? We've already got a 6. What do we have to multiply a by to make it into a squared?
A.
We need another a, right? We've got 1, we need to have 2. So bottom and top. What do we have to multiply b to the 4th by to make it into b to the 4th? Nothing, right? It's already b to the 4th. So in this one, all we have to multiply by is a. So this will be 4ab. Okay. Now, let's go ahead and add these together, because that's our goal. Now, do we have any like terms here? Remember like terms, the variable parts have to be exactly the same. Are they exactly the same? No, this one is ab cubed, this one is just ab. So when we add these, it's just going to be 14ab cubed plus 4ab over 6a squared. A squared b to the 4th. I just realized I did something kind of stupid. Because, I guess we'll use it as a learning experience, right? Because what do we have to do at the end to see if we can do any factoring and reducing and things like that? I just gave it away. We have to factor and see if we can reduce. So what can we factor out of this numerator? Start with the numbers. What number could we factor out of the numerator?
7. No.
2, right? 2, we could factor out a 2. And then what about the a's? How many a's could we factor out? A, just one a. And how many b's could we factor out of both?
B.
Just one b, right? Because they both have that. And then what's left in this first term after we factor out a 2 from the 14, be a 7. After we factor out an a, that's gone. After we factor out a b,
B squared.
b squared. And then plus. Then we go to the second one. After we factor out the 2, what will be left here?
Just 2.
Yep, it'll be a 2. After we factor out an a, That's gone. After we factor out a b, that's gone. Okay. And then on the bottom, we have 6a squared b to the fourth.
We can.
We can
divide
reduce.
2. Yeah.
We can reduce. So here's where I should have been thinking about this earlier, but I wasn't. I was focused on the adding in the common denominator. So 2 can reduce with the 6, because notice this is times, 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 right? So, and this is times, times. So 2 can reduce with the 6, and this becomes a 1, and this would become what? If you reduce them both by 2, what would this
3.
become? A 3. Here we have an a on the top and an a squared on the bottom.
A.
So this 1a can cancel, and we have 1a left. And then we have a b and a b to the fourth. So this b can cancel. And then we'd have how many left down here? 3. So our answer would be 7. Let's see if we can still see this. 7b squared plus 2 would be our numerator. And then we would have 3ab cubed as our denominator. And I'm going to show you how dumb I was, and I apologize for being dumb. Okay, does everybody have this work down if you wanted it? Because I'm going to erase it except for the answer. Because I should have been smart, and I wasn't smart. Okay, everybody good? You can choose to write this down, or you can choose not to write it down. We're going to get the same answer, but I think this is going to be a little bit easier, and I'll show you why. What I should have done at the beginning was reduce each fraction right away. Okay? So do we see that in this first fraction, there's an a on the top and an a on the bottom? So can't we cancel this 1a and this 2 a's, and now there's only 1 left? Okay, so this becomes 7 over 3ab. And then notice with the numbers, what can we cancel with these or reduce by?
2.
A 2. So this would become a 2, and this would become a 3. There's no a's, but we've got a b and a b to the fourth. So what happens when we reduce or cancel that? Yeah, this cancels to be a 1, and this cancels to be a b cubed. So the second fraction would be 2 times 1 over 3ab cubed. And that makes our common denominator easier to find. So let's take a look. What number do I need to have now? This is actually really easy, so don't make it complicated. They both just have 3s. We need a 3, right? How many? A. What's the largest number of a's that we need? Just an a.
B cubed.
And then the largest number of b's is b cubed. Okay, so now I've already got a 3. I've already got an a. How many b's do I have to multiply by?
B squared.
I have to multiply by b squared. Top and bottom. That'll give us 7b squared. And where's my blue? The second one, we've got a 3, we've got an a, we've got a b cubed. We don't have to multiply by anything, right? We've already got the common denominator. And then look what happens. 7b squared plus 2 over 3ab cubed. So if we can do the reducing at the beginning, it will save us that work at the end. And I should have looked at it right away, but I wasn't paying attention because I was all worried about getting a common denominator. Do you ever notice that if you're worried about one thing, you make everything more difficult than what it actually had to be? At least that happens to me sometimes, like right now. But it happens in life sometimes too, doesn't it? If we worry about things, we make them more complicated than they need to be.
Okay.
All right.
All right.
Oh wait, is everybody okay with that?
Fine.
You like the faster way easier, better?
Yeah.
Yeah, me too. I got to the end and I'm like, what was I doing?
If we write the same answer, but we write it different way, is it okay?
Different
right?
method of getting there?
Yeah.
Yeah, as long as you get the right answer.
I mean,
My goal as a teacher is to try to show you the easiest method and hope that you will use it. But sometimes there are sometimes more than one way to do things, but one way will always work and other things will not always work. Like our shortcut method on the factoring. I didn't show you that at the beginning because I wanted you to know you can factor all of these things the same way. And now that we had our test over that, we've done a lot of practice, then I'm like, okay, well, let's take a look at it and see if we can understand the shortcut. Are we good with 349? Example 349? All right, let's go on. Of course, now I'm not going to be dumb, and now there's no reducing we can do. Jerks. All right. So, but the one thing we do want to change is we don't want to subtract, right? So we're going to change this to plus and then make that a -7. Okay, notice each term, there's only one term there, but each term gets its sign changed. Okay, so looking at our common denominator that we're going to find, if we have a 5 and a 4,
20.
what would the common denominator be? And yeah, they don't have anything in common, so 20. And if you're not sure, 5 is prime. You can't do anything with it. 4 is 2 times 2. So least common denominator, well, we need the 5 and we need the 2 times 2. And if you multiply those all together, we get 20. Okay, so if you're not sure, you can always do that with the numbers. Then we look at the A's. What is the largest number of A's that we see here? Two of them, right? So we're going to have A squared. So that's going to be our common denominator. And we were smart this time, and we looked to see if we could reduce, so it should be a little bit better. What do we have to multiply the 5 by to turn it into a 20? 4. So we're going to multiply the bottom and the top by 4, numerator and denominator. What do we have to multiply the A by to turn it into A squared? We've got 1A, and we need to have 2 A's. So we're going to multiply by 1A. Okay, so 4A, 4A. When we multiply 5 times 4, we get 20. A times A is A squared. On the top, it's 4 times A, which is 16A. For the second one, we've got a 4. We need to have a 20. What do we have to multiply 4 by to turn it into a 20? A 5. And we have an A squared. What do we have to multiply it by to get A squared? Nothing. It's already A squared. So all we have to multiply by on that one is a 5. And -7b times 5 is -35b. Okay. And then once they have a common denominator, we add the like terms. Do we have any like terms that we can add? And the answer is no. So we just write 16a minus 35b over 20a squared. And I think, at least in some of the questions, there's a fraction button that you can choose. And so you'd put your top and then your bottom. If you just start typing it, I think you can select the whole thing and then do a divided by sign, and it will turn it into a fraction. But you may have to kind of work with that a little bit as you're going through the problems. Any questions on that one?
So we just multiply by 5 now.
Yeah, well, this is a 7b, that's all one term. So when you multiply terms, you just multiply the number parts together, and the b just stays there. Because if it was a plus sign in between the 7 and the b, then we have to distribute. But there's no distributing. It's just 5 times 7b, 35b. Or negative 35b. All right. Let's take a look at this one. Now, up to this point, we have not had to factor any of our denominators, right? We did a whole bunch of factoring in the last couple of lessons, but we haven't had to yet. In this one, we are going to want to factor. So let's take a look. We've got, how can we factor this 8a plus 4? How could we factor that?
Well,
Factor out of 4. What is going to be left inside the denominator then?
2a plus 1.
2a plus 1. Okay, and then plus, and then 3a over 8, we can't really factor that. Okay, now, if we're being smart, do we see that we can reduce the 6 and the 4?
Mhm.
Okay, it ends up not being as smart this time, but we still should look for it. And we can reduce the 6 and the 4, and this becomes what on the top?
3,
Because what can we divide them both by?
3, 2.
We can divide them both by a 2, so this becomes a 3 and this becomes a 2, right? So now we have 3 over 2 times 2a plus 1 plus 3a over 8. Okay. Now we need to get our common denominator. Is it pretty clear we're going to need the 2a plus 1? Because what's the biggest number of 2a plus 1s that we see? Well, there's a 2a plus 1, so we need that. Does that make sense? Now we have to figure out the number part. With a 2 and an 8, it's going to be an 8. Now, if you're not sure about that, let's see why. 2 is obviously just 2. 8, if we break it up, is 2 times 2 times 2. So if we choose the biggest number of 2's, how many 2's do we need in our least common denominator?
4.
No, because remember we're dealing with each group separately. So we need 3. Okay, so each group is its own entity, I guess, its own group. So we need 2 times 2 times 2, which is 8. And so that's why we choose the 8. Okay, now, looking at this first fraction, what do I have to multiply the 2 by to turn it into an 8? 4. And what do I have to multiply the 2a plus 1 by to turn it into a 2a plus 1? Nothing, because it's already there, right? So we're just going to multiply by 4, and that becomes 12. 3 times 4. Then we go to the second one. What do we have to multiply the 8 by to turn it into an 8? Nothing, right? It's already an 8. But we've got nothing here, and we need to have 2a plus 1. So what are we going to have to multiply by? We have to multiply by the 2a plus 1. Does it make sense? That'll give you 8 times 2a plus 1, and that's what we need, right? 8 times 2a plus 1. And we have to do the same thing on the top. Now remember, the denominator, we're not going to multiply that out. We're just going to leave it in factored form. In the numerator, though, now is the point where we're going to have to distribute, and we're going to have to simplify that numerator. So when we multiply this, remember, we're going to distribute. So what do we get when we take 3a times 2a?
6a squared.
6a squared. Okay. And what do we get when we take 3a times 1? 3a. And now they have a common denominator. So we will simply add the like terms. Our denominator stays the same. So it's going to be 8 times 2a plus 1. And as we add straight across, we're going to have 6a squared. Excuse me, 6a squared plus 3a plus 12. Does that make sense? Now, is there any factoring we can do in our numerator? Because the denominator is already factored. Is there any factoring we can do in our numerator?
3.
We can factor out a 3. And that leaves us with 2a squared plus a plus 4 over 8 times 2a plus 1. Okay. Now, doesn't that 2a squared plus a plus 4 look like something that we've been factoring in the past?
Yes.
Okay, let's check it out. We would take 2 times 4, which is 8. And where's my red? And this is a positive 8, right? Which, what does that tell us about the signs that we're looking for?
Positive or negative.
They're either both positive or both negative. And then I'm just going to use an arrow here. Then we can see that this one is also a positive, which means both positive. So factors of 8 that are both positive and add up to be 1. So we would have 1 and 8. Does that add up to be 1? No. 2 and 4. Does that add up to be 1? 3 doesn't go into 8, and then 4 and 2, but that's just a duplicate, right? So what does that tell us if we can't find any numbers that will add up to be this? It means we can't factor this. So we're done.
We're done.
We're done with that one. We tried to factor it. It doesn't factor, so there's obviously no reducing that we can do, and we're done. Okay. Any questions on that one? Right. And I understand these problems all look a little bit different probably, but as you look at them, honestly, we are doing the same thing every time. We're reducing if we can, we're factoring our denominators, we're finding a common denominator, and then adding them together. So, all right, what do we want to do first here? Yeah, I would suggest go, and I'm just going to use my special quick method of changing the signs like that. So now we have addition, and we have x, a negative x, and a negative 1. Now, I'm not going to let you off the hook as easily this time. We are going to factor something here. So let's factor this x squared minus 7x plus 12. And our first step is multiply 1 times 12, which is 12. It's my colors. This is a positive 12. So what does that tell us about the signs of the numbers we're looking for? Both positive or both negative. Okay. And then, since this is a negative, we know that they both have to be
Negative.
negative. So factors of 12 that are both negative. Negative 1 and negative 12. Does that add up to be negative 7? No. Negative 2 and negative 6. Does that add up to be negative 7? Nope. -3 and -4. Does that add up to be -7?
Yes.
Yes. And do we see that this time we can use our shortcut? Because it's just an x squared. So our factors will be x -3 and x -4. And the top we already know is -1x minus 1. Okay. So now we want to get our common denominator. And we see that there's an x -4. What is the largest number of x -4s that we see in either of these two denominators? Just one, right? There is one in each, but the biggest number in each is just one. So we need an x -4. And then we have an x -3, and we're going to need that as well. Okay. So looking at this first fraction, if this is our denominator and we need to turn it into this, what are we going to have to multiply by? Because we've already got this, right? We have to multiply by x -3. Top and bottom. Okay, I'm going to leave that for a minute because we're going to have to multiply that out. So, or let's go ahead and multiply it out. Again, we're distributing. This will be x times x is x squared. X times a -3 will be -3x. 1 times x is 1x. And 1 times -3 is -3. Okay, so we've got our distribution there. Going to the second fraction, we've got this. What do we have to multiply this by to turn it into this? We've got the x -3. We've got the x -4. We don't need to multiply by anything. We've already got it. So we're just going to write down a -1x and a -1. And now we combine our like terms. So we've got the x squared. We've got a -3x, a +1x, and a -1x. What do we get when we combine all of those? -3x, because really these two just cancel, right? One's positive, one's negative. And then we've got a -3 and a -1. And what does that give us? -4 and okay, so again, looks like something we might be able to factor, right? I think they were not very nice to us. I think this one's going to factor again. All right, so multiply. So let me just do this here. X squared -3x -4. Multiply 1 times -4. That is -4. Since it is a negative, what does that tell us about the signs of the numbers we're looking for?
Different.
Yeah, one is positive, one is negative. Then, since this is a negative, what does that tell us?
Negative is bigger.
The negative number is bigger. So if we're looking for factors of -4, where the negative number is bigger, we would have a 1 and a -4. Does that work? 1 plus -4 is -3. So yes, that works. And again, this is our shortcut method. So what can we write down as the two factors of the numerator? X plus 1, x -4, and then x -4, and x -3. And so what do we see here?
X -1, x -1.
Yeah, these can cancel out because these are identical. And our final answer, x plus 1 on the top, x -3 in the denominator. And that would be your answer. Okay. Any questions there? She's ready. She's got her sprinting shoes on. She's down in her sprinting
Yeah,
stance.
yeah.
Okay. So there are 8 graded problems there on that one.
Okay.
Remember that next week, and I apologize, I did not send out a weekly announcement this week because it was just normal class stuff. So, but next week, we do have class next Tuesday. We'll have our test over chapter 7, which is all this rational expression
All
stuff.
the difficulties.
So I will be here again at 6:30 next week. So if you guys have questions, I will answer as many questions as you guys have until 7:30. If you guys run out of questions, then I will stop.